So we'll be looking at what are collections. A collection represents a group of objects. That's it. Very simple definition. A collection is nothing but a group of objects. Objects can be string objects, integer objects, your own user defined objects. You put some group of objects together, you create a collection. So let me take an example of a collection. So some objects, you're just going to put these objects together. You call them what? A collection. So when you have such a collection, what are the common methods you can think on a collection? Some of the common methods are, first thing you can get into your mind is you can add another object to your collection. Adding an object is one thing. Once when you add, you can also remove. Say I want to remove one particular object, I can remove that. So adding objects, removing objects, size. How many elements I have in my collection? So size is also another thing I'll be interested in. Is empty. I can check whether the collection is empty or is it having any object. So these are some of the common actions we'll perform on any collection. Contains object. So this is for searching whether an object of this particular type is present. I mean whether object 2 is present in my collection. Searching for an object is also another common method. Clear. What do you mean by clear? Remove all the objects from my collection. So when you think of any collection, these are some of the common methods on any collection. Let it be of any type, either string or your own user defined objects. A collection can also have sub collections. In the sense, you can attach some properties to your collection and say it is of a certain type. I just go with this. Say I have a list of objects, and for these objects, I say in my collection duplicate elements are allowed. So I have a group of objects. You see, object 1 is repeated twice here. So I can have duplicate elements. And order of insertion should be maintained in the collection. So if in my collection, if I insert an object, when I retrieve the entire list of collection, the order of insertion should be always maintained. So how will I maintain the insertion order? How will I know that a particular object was inserted here and a particular object was inserted there? So while I retrieve, it will be on the same way it was inserted. How will I know? Using an index. So index starts always from 0, right? In Java, it starts from 0. So for every object, you'll have an index. So using this index, so while you insert, you'll know where, in which index you are inserting. While you're retrieving, you know from which index you are retrieving. So using index, you'll be able to maintain the order of insertion. So when you're performing all these things on a collection of objects, and when your collection has got these properties, you call that collection to be a list. You can name that collection to be a list. So what are lists? Duplicate elements are allowed in my collection. Insertion order is very important. So such collections are called lists. One of the important thing is you'll maintain indexes to maintain insertion order. So list is a type of a collection. You all agree? It is containing some objects, but we define some properties and say this kind of a collection is a list. So when you take a look at some of the list specific methods, for lists alone, what kind of methods I can have? Adding an element in a particular index. I want to add in index 1. So that is one list specific method. Getting an element in a particular index. What is the element in index 2? Setting. Say I will go to an index and replace that element there. So all these things are very specific to a list based collection. Removing an element from an index. So lists have these specific methods. Whereas list is also a collection, right? So collection methods are what we have seen about collection methods: adding, size of the collection, whether the collection is empty, searching the collection. These are methods for your collection. List is a type of collection which is having very specific methods to it. But list is also a collection. So list will also have all the methods for a collection plus its own specific methods. So what we understand here is list extends collection. Got it? I told you lists lists store elements in an order and they can allow duplicate elements. But even lists have some subtypes. So these subtypes are based on how you store the elements in your list. Say I have some elements in my list, right? So I have some duplicate elements, I have some elements. Before storing them, I'm looking in for a one block in my RAM wherein I can put all these elements together as one contiguous block. So if I have this, say this is the space on my RAM, it is a contiguous block of memory. So if I put all my objects next to each other, consecutive locations, and then I have indexes to, reference each of them, then such type of lists I can classify them as array lists. So what do you mean by an array list? It's a type of list, it's a type of a collection. Whereas what is the important point here? You put all the objects in one block and then you store them together. So what is the advantage if you put them in a contiguous block? Reading will be more faster, and then you can think of sorting and things like that, which will be more efficient. But what is the other problem? If your process wants to, hold all these objects, first it should look for a block of memory wherein it can put all these things together. So till that block is available, it should wait. So it's not actually write optimized, it's read optimized. So array lists, that is what an array list is. Array list is a type of a list. So uh, we'll be looking at array lists now, and even before that I want to show you the collection interface framework in Java. You have this collection which is an interface, it is on top of all the interfaces. So what this collection has got is the generic methods, like adding an element, is it empty, what is the size of your collection, removing an element from your collection. So for any collection, let it be a list or linked list or stacks or queues, whatever it is, you'll have all these common methods, right? So that is defined in your collection interface. Whereas list extends collection. So what is this list? It allows duplicate elements and it is maintaining the insertion order. So list is a type of collection, right? So list is also an interface that is extending the collection interface. So you have all these methods, abstract methods in your collection and list. Whereas what is array list? Array list will implement all the methods in collection and list. So collection is an interface, list is an interface. List interface will have methods specific to the list, like setting, adding an element in an index, removing an element from the index. Whereas collection will have generic methods like add an element, remove an element, and it will be very generic. So what is the size of the list, size of the collection, like that. So both these interfaces will be extended by array list. Array list is actually a concrete class. So it will be providing the implementation for your methods in your list and your collection. Right. So what we'll do is we'll now go and create an array list. You understood what an array list is? So we'll go and create an array list. We'll see how to create an array list. Let's look at these properties. So how will you create an array list is, some more definitions of an array list. It uses a dynamic array. The array size can grow or shrink during the execution of a program. So you all have learned vectors in C++. So you know what a vector is. It's a dynamic array, right? During the execution of the program, the size of the array will be doubled every time when the size increases. So the same kind of a concept here. It is a dynamic array that grows or shrinks during the execution of a program. It can contain duplicate elements because it's a list. Insertion order should be maintained because it's a list. And retrieval of elements happen using an index. Index starts from 0. That's an array list. You already have an array. Why should you go in for an array list? That is the question I asked you. You know how to maintain array of objects, right? Why you want to have an array list of objects? As I told you, it's a dynamic array which can grow and shrink while the program is executing. And one more thing is you have a lot of methods supported for this class. Like in an array, if you want to delete an element, you have to shift everything on your own, right? You have to write code and shift. So deleting and insertion is a very big problem when you maintain as plain arrays. Now you have this array list. It internally uses an array, but you have a lot of methods that support insertion and deletion. So we'll be looking at all these methods now, and we'll see how to create an array list. How will you create an array list? You give array list, and here you are seeing something new, that in angular brackets I'm specifying the type of objects that will be residing in my array list. Array list comes under the generic methods and classes in Java. So anyway, we all have learned templates in C++ in your first year. The same concept. So it's a generic class. You can maintain any kind of object in its arrays. So when I want to maintain an array of string objects, I'll give string here. If you want to maintain an array of integer objects, I'll give integer here. So I'm creating an array list of string objects, give the name for that object, new, and then array list. Okay. So once when this array list is created, what you're going to do is you're going to go and add objects. How will you add objects? You will add, this is the method for adding. Add, and we are giving E and E. What is this E? It is a generic type. It can be, you can add an integer object, you can add a string object, you can add your own object that you have created. So it is a generic class, a generic type. So we don't say it's integer or string here. You add an element. So you can add an element. You can add an element in a particular index because it's a list, right? You can add an element in an index. You can remove an element from the index. You can clear all the elements. So let us dive into code. Let's do some code now. So it's very easy, not like your threads. So let's go and create an array list and store the names of some of the students. So how will you create this array list? It's ARRAY, and then it's array list, right? List. So immediately it gives me the angular brackets. Say if I'm going to store array list of strings, I'll give string here, and then the name, yes, and then new array list. That's it. Your array list is ready. Next thing is you have to add some objects to this array list. How will I add? You give the object name for your array list, s dot add method, and then it's an array of strings. So I'm going to enter some names here. Satish is the first object entering. So like that, if I want to add more objects, s dot add, and then I can add Ram is another object. S dot add chef is another object. So I have created a list of objects using an array list. So when you add an object in an array list, what it does is it internally uses an array to store your objects. So you can go and very well see that code in Eclipse. I just pasted that code here. So this is the code for adding an element in your array list. So what it does is it uses an array, increment the size of the array, and pushes your object to that array. So it's plain array wherein it stores all your objects, but it has got all these methods which makes our life easier for inserting, deleting, and things like that. So did you all create an array list and add some elements? So how can I go and print all the elements in my array list? I will tell you how to do that using a for loop here. So what is the size of my array list now? If I print size, the method for printing the size is s dot size. It's not length here, it's size. So if I go and run this one, I'll get a size 3. So my size of my array is 3. So what I will do is the index starts from 0, right? So I'll have this like this for int I is equal to 0, I less than s dot size. So I plus plus. What I'm going to do is sys out. So I'll get every element from my array. For getting every element from my array, I'll do s dot get. And this get method gets the index as the parameter. So for index, I'll give I. So index will be varying from 0, 1, 2, 2. So s dot get will get every element in my array list, and the index varies. So you can go and have a string k is equal to s dot, and then you have to typecast it to a string s dot get. So every element we are getting in k, which is a string, and then we will print this k out. Yeah, if you directly print that also, it's going to print all these strings. Yeah, that's what it will print. But why did I go with this kind of cast is we'll be storing any kind of objects inside our array list. Even it can be our own user defined objects. So it is good to typecast it when you're going on with your own user defined objects. See, if you directly go and what he says is if I just go and directly print this out s dot get I, it will print all the names. It's not a problem. But why did I tell you this way of doing things is if you are going to have your own user defined objects created and stored in an array list, you are retrieving it one by one, then you will need to typecast it and get the data and print the data out. So we'll be dealing with that one too. So right now, were you able to get all the data from your array list? Is that visible to you? Did you execute this? Okay. So what all things, other things we can do with our array list? We'll go and see that. What are the other methods we have? We can add an element in a particular index. So you give add index and then the element. So let's go and add an element. Say I have Satish, Ram and Jeff. Satish in 0 index, Ram in 1, Jeff in 1. Jeff in 2. So instead of Ram, I want to add Chris there. So how will I add? Say I'll just do s dot add, and now I'll use this index method wherein I'll give add in 1. What element I'm going to add is I'm going to add Chris. So right now in 1 there is Ram. I am inserting Chris in the place where Ram is. So what should happen from within the array? Chris will be pushed at 1, and then all the other elements will be pushed to the right. So here you see Satish, Chris, Ram and Jeff. So these are some of the advantages we have. If you are going to maintain it in your arrays, you have to write code for all these things. Now ArrayList helps you out with such methods. So you see that jump happened. Ram jumped from wherever he was to the next location. Jeff jumped to the next location. Suppose I don't like Chris, I want to remove him. How can I go and remove him? I can just go and do s dot remove, and then I can give the index from where I want to remove. I want to remove Chris, so I'll give index 1. So Chris gets removed, but that place is empty, right? So you have to push Ram back and Jeff back to their location. So if you go and do that, you can see now you'll have Satish, Ram and Jeff. Everything is done for you. So we have seen removing an element using an index. What is clear? Clear will clear everything. S dot clear. So you'll not have any elements to print if there is a lead to an issue actually. Nothing in your test. Size I told you will return the size is empty. What is this is empty? Will return true if it is empty. Let's go and say we have cleared all the elements. We'll do check is empty or not. So we'll check s dot is empty. It's a Boolean function. So it should be true. After we cleared all the elements, it should return a true because it is empty now. Yeah, empty is true. So you can also search for an element in your list. In your array list, how will you search? So you just do contains and you just give the object. So how will I search for an element? Say if I want to search for Satish, whether he is there inside this list. So it is s dot contains, and then I give the object that is Satish. If it contains Satish, it will return true. So it contains Satish, but it's actually returning false because we have cleared the collection and then we are checking whether it contains. But now if you just run it like without clearing, it will return a true. See, it's true. If See, there's one more thing, public int index of object O. So if I give this object, it will return me the index of the first occurrence of that object in that particular list. Say if I have Satish, Satish, and then Ram, Ram, if I search for Satish, the first index is 0. So that will be returned. If that element is not present, then -1 will be returned. So you'll search for anything like you can use index of. So say I'll use s dot index of and then get me the index of Satish from my list. So this will return actually 0 because Satish is in index 0. If you have many such items with the same value, then the index of the first value occurring will be returned. Okay. There is a last index of 2. So what last index of does is it searches from the reverse. If your list, you're searching from left to right, the last index of will search the list from the end. Object clone. You know what is clone, right? We have learned already with arrays. When you do a clone, it does a shallow copy of your object, your array list. So you can copy one array list to another array list. So can we try copying this array list? Say I want to copy S to another array list K. So I'll create this new array list, new array list. So it's, and it will also store an array of strings, and then I'll call that to be K. And how will I clone this array list S? It's just S dot clone. But then it asks you to typecast. So that's it. So you have done a clone of S, you have copied it to K. Suppose I want to print everything in K, it's just K dot K, string J, something like that. So I am just printing everything that I copied to K, right? I am printing everything in that particular. So now when I run all the elements in K, I should be getting Satish from Jeff. Yeah, you see Satish, Ram, and Jeff. This is a search that we did, index of Satish. So we'll comment that one out now. So you know how to clone one array list to another array list. Is this clear? Very easy. Yeah. Should store only objects. So integer, string, we should not store int, eger. Yeah. Okay, now we look at traversing an array list. See, when you talk about a collection can contain any kind of objects. And the objects, it's not mandatory for the objects to be always stored in one single block. The objects can also be stored on several parts on your RAM. So normally a for loop will not work for traversing through your list of objects. So what we have for traversal is you have a separate interface called an ITraitor. So what this ITraitor does is it helps you with respect to traversing from one object to another object. You no need to worry where that object is stored, how you are going to go to the next object in a list. When you use an iterator, it takes care of taking you to the next object in the order of the insertion. So you have to define an iterator to traverse through your objects in a collection. So let us go through the various things. We have seen how to use a for loop, right? And print all the elements in the collection. let's use a for each consumer action, that is an enhanced for loop. So I will use an enhanced for loop here. Will that help you out? So if I give for each and then control space, it'll just take me and build me this. For every string in my array k, which I have cloned just now, what I should do? Sys out, put the string out. That is. So if this will just print, it's an enhanced for loop. That's it. Nothing new here. So you can use an enhanced for loop to print your elements in the list. So now I told you, right, you need an iterator to travel through every object in your list. So ITraitor is again an interface, and we are going to use this iterator to traverse through our objects in the list. So what we'll do is we'll go and use it. So instead of the for loop, first I should create an iterator. So object iterator itr is equal to. So what is the array list object name? It's s dot and then I say iterator. So now I have created an iterator for my array list. So how will I iterate through my every element in the array list? I will give a while itr dot has next. So if your iterator has more elements in the list, what you are going to do is we are going to do get every element. So how to get every element is it's itr dot next. So dot itr dot next will get every element from that collection. So what is the element that's coming in? That's a string, right? I can say string j is equal to itr dot next, and then I should also typecast it to a string. So you define an iterator, and then you say while iterator as dot as next. So while the iterator has many other objects in the collection, it will fetch everything using itr dot next. So iterator dot next will fetch me one element from the collection. So I know that's a string. So it is asking me to typecast to a string before I store it to a string. And then I can print that string out. So it is J. Okay. So Satish, Ram, and Jeff. Have you all finished the iterator? Can I go to the next concept? So you have a list iterator. What is this list iterator? It is very specific for collections that are of type lists. What are the collections that are of type lists? Array list is a list collection. So you can also use a list iterator. So an iterator, what it does is, say if you have some 5 objects, 1, 2, 3, 4, and 5, an iterator will start from the beginning, from index 0, it will go till the end. Whereas a list iterator has got some more specific methods, like it can also traverse it from the reverse. You can traverse the list from the reverse when you are going to use a list iterator. You cannot traverse the list from the reverse by just using an iterator. So in the previous example, we have used an iterator. Now we'll go and see how to use a list iterator. It's very simple. Instead of iterator, you give list iterator and then create that iterator. So what we'll do is we'll now go and create this list iterator. So instead of iterator, you just type list itr and then you do a control space. You're working on Eclipse. And then this list iterator is going to work on an object of strings, and then you give the iterated name itr is equal to what is the array list object name s dot list iterator. So we have created a list iterator. We'll traverse from the index 0 to the end. How will you traverse? So it's again the same. While itr dot has next, you get every element from your list. How will you get every element? So you have this itr dot next will bring every element, but every element is a string. So I'll give string j is equal to itr dot next, and I'll also typecast it. So now I can go and print every element. Sys out, we'll go and print this j. So if I go and run this one, It'll again print me Satish, Ram and Jeff because we are starting from the beginning and then we are going to the end. But I told you a list iterator will also run the traversal in the reverse. So to run the traversal in the reverse, you have to start from the end of your list. So how will you know the end of your list? It is list.size. So s.size gives me the end of the list, right? So what I will do here is in my list iterator, I'll just give s.size. So it will start from the end, and then it should not use dot as next. It will check as previous. So very simple. It will check as previous. If there are any elements from the end, so it check whether there are previous elements. So instead of itr dot next, it's just itr dot previous. That's it. So you give the size as an argument for your list iterator, and then you do while this dot has previous elements. You get every element using dot previous. Now you go and run this one out. You should get Jeff, Ram, and Satish in the reverse order. So it's traversing it from the reverse, right? So you see Jeff, Ram, and Satish. A list iterator can be used only on collections that are of type lists. You cannot just like that use it on any collection. You have many collections, types of collections. Here we are focusing on array list today, which is a list based collection. Okay, so we have done all these things. List iterator also we have done, traversing in the reverse. So you can create an array list, you can create a collection using another collection. So I have an array list, I can create an array list using another array list. So I should just pass that array list as an argument to my new array list. So what I will do is, let me go and show it here. Say I already created this array list. Let me go and create another array list. Let me delete all these statements first. Let's make our code more thing. So let's me create another array list. So it's a new object, right? So it's an array list of strings, and we'll call this name array list is equal to new array list, and then I pass this s here. That's it. So s is again another array list we have created previously. Now whatever elements in s will be used for creating this array list. So now if I go and use this name and then create an iterator for name, so it's just name dot iterator, and then we'll go in from the first. Let's not go from the reverse. So we'll say dot as next. So very simple. itr dot next. So what I've done is created another array list using one more array list. So let's go and run this one out. See, so you can create an array list using another collection. That's what they mean. So that collection is passed as an argument s here. So there is one more thing. Say you can create an array list like this, or else you can also add elements from an array list to your list. Say I have one array list s, I have another array list name. Say in name I'll have name dot add some elements I'll have for array list name. So test1 and test2 in my array list name dot add. So we'll have some test1 and test2. See, the thing here is I want to add all the elements in S to my already created array list name. So what I can do is I can now go and use a method name dot add all, and then I can give the collection name, that is S. So what it does is it takes all the elements in your array list S and then adds it to your array list name. So now if I put all the elements out from name using the list iterator, what is happening? You can see test1, test2, Satish, Ram and Jeff. So Satish, Ram and Jeff got added at the end of the list. So name is the list having test1 and test2. Name dot add all s. What it does, it brings everything in s and moves it to this new array list. So if I want to remove all the elements only corresponding to s from my array list that I have created, how can I do that? For that also they have this function name dot remove all. So you give remove all and then you say yes. So it will remove every element corresponding to s from your collection name. So how easy it is, right? So I added a Satish, Ram and Jeff. I also removed that particular names. See, now only test1 and test2 is there. You also have retain all. Say I've added a collection to another collection, but then I want to retain only elements of the added collection in that list. I want to remove the existing names from that. So I can go with retain all. So what we'll do is say, we'll not remove this. I just run this code. I add two collections, right? One is yes and one is name. So once when I add both these things, what happens? You can see here, test1, test2, Satish, Ram and Jeff. But I want to retain only Satish, Ram and Jeff. So retain will retain only whatever collection that you are giving, only those elements it will retain. It will remove test1 and test2. So retain, let's try name dot retain. So in this collection, only retain elements of the collection I am passing as an argument. So it will retain only S and remove test1 and test2. See? So from name, it has only retained whatever values corresponding to S. Test1 and test2 got removed. So we have done so much on ArrayList. I think I have covered much of the methods. We'll take one more kind of lists. So list extends collection, array list extends list. There is one more type of list called the linked list, very familiar to you, right? You have learned the linked list in data structures. You know the advantage of going to a linked list from an array. You know the disadvantages of a linked list too. Who can tell me all these things? Yeah, we'll give an opportunity to him. Yeah, please tell me. Hmm. Okay. Yeah. Yeah. That's good. So I hope you all had a course on data structures, irrespective of your branches. Anyway, I'll just show you what happens. Say in an array list, what it does is it waits for a block, a contiguous block to push your objects. But here, say on my RAM, I have some places already occupied, and then I have some free slots. Say I want to write three objects. I'll not wait for a contiguous block. Wherever space is available, I'll go and start and write. So write, it's actually write optimized. Writes will be faster. Your process will not wait for a big contiguous block to write all these things. But then how will you link object 1, object 2, object 3, because it's all in different places, in different addresses. So how will you link is you'll have a pointer from object 1 to object 2. There will always be a link. Okay, after object 1 I have inserted object 2, and after object 2 I have inserted object 3. So you'll have links or pointers pointing from one node to another node. So in a linked list in Java, as you told, it's a doubly linked list. You will also have pointers in the reverse, right? So you will also have from object 3 to object 2 a pointer. Then from object 2 to object 1 a pointer. So you can traverse in both the directions. So that is a linked list. For an array list and a linked list, the methods are almost the same, because it implements the list methods and the collection methods, right? But the way when you add an element for an array list, it uses an array and then stores the object, increments the array and puts the object inside the array. But when you use a linked list, when you add an element to the linked list, it will not create an array, it will create a linked list. The code behind that is a data structure code. That is, it is maintaining a linked list internally for you. It's hiding all the code from you, but you will use just add element. It will just put that element in some place, create the pointer and store it internally. So the methods are almost the same, add, remove, or whatever it is, but the way it stores the data is the difference. So you can go and say linked list is also used as a list, as a stack. So you know this stack concept, right? And also a queue, a double-ended queue. So you can go with all these implementations using this particular concept called linked list. So we'll see first the list, how to create this linked list. So it's very simple. You go on, give your, instead of an array list, you just give linked list. Say you want to create a linked list of strings, you just specify this linked list string, yes, new linked list. Everything again repeats. Its internal storage alone is different. So you go and add an element, it will add, and then it will maintain all these things. See again, insertion deletion. The another advantage is insertion deletion is not costlier, because when in an array object, when you insert something, you have to keep on pushing everything to the right or everything to the left based on the things. Here it will be just a change of the pointers. Garbage collection takes care of the remaining things. So it's your internal choice whether you want a read optimized application or a write optimized application. So only thing is, you can go and perform the same things you did with your array list. Clear, remove from an index. Set is like replace an element in a particular index with a new element. And again you can use list iterator that we have done to move forward and move backward. See, this linked list also inherits not only from the list, it also inherits from the queue interface in your collections framework, so that you can implement a double-ended queue using the concept of linked list. But for cat2, we'll not focus on the queue concepts. We'll only focus on stack and how to create a linked list. So now why don't you create a linked list? Say there's two more methods here, push and pop. When I say s dot push an element, it'll just maintain your linked list as a stack. Push it and then pop, it'll pop whatever element that was pushed just recently, right? So you can create a stack. So why don't you write an application now that imitates a stack using our linked list? So you should give the option for the user. Let it be an integer stack. So you give the option for the user to push some elements into the stack and pop some elements. So if he says pop, it should pop. If he says push, it should push. If the stack is empty, it should say no elements to pop. So even before that, can we try creating a list iterator? Quick. I mean, linked list collection. So how will you create this linked list collection? So let's go and give linked list. Linked list, and then a list of strings we are going to have. S is equal to new linked list. That's it. The same thing applies here too. You can also create a linked list by using another collection. So you can pass that collection object as a parameter here, like what we did for array lists. So let's, how will you go and add an element here? It is s dot add, and then I'll add Satish. And then I can add another element, s dot add. I'll add Ram. So now these elements are not going on to any array. It is all maintained as a linked list data structure. Okay. So s dot add, again we can add some. The functions are the same. Okay. Now if I want to iterate through the linked list, how will I do that? I'll do a list iterator. List iterator. So you have this list iterator. It will iterate on strings, and then itr is equal to the linked list object name dot list iterator. So while itr dot ask next. What you're going to do? You're going to get every string j is equal to itr dot next. Dot next will fetch the string, and then you can also just like it print sys out j. Okay, so it's exactly similar like what you did for array list. Only thing is internally the implementation is different. See Satish, Ram and Chris. If you want to traverse it in the reverse, you give the size s dot size in your iterator and then check dot as previous, and then you just go in the reverse. So can you go and implement a stack? Say if I want to use it as a stack, I'll just use s dot push and then I'll put some string, and s dot pop will pop that string which got recently pushed into your stack. So you just give s dot pop. So whichever went into recently, say sat went into recently, will be popped off. So you can create a stack. You give the option for the user to either push or pop until he wants to exit. Create a stack. Again, ArrayList, another program I am giving you. Create a student class. Create an array of create an array list of student objects. Iterate through the list and print the student name and registration number. So you have seen creating an array list for strings. How will you create an array list of student objects? Can we go and try code that student object? Let me try creating an array list of student objects. User defined objects will try. So class student, and then say yes, two variables, string name and string registration number. So string name and string registration number. So we'll have a parameterized constructor for this guy, for this class student. So will you generate a parameterized constructor? Go to source, generate constructor using fields. Generate, that's it. So the parameterized constructor is ready. Maybe we can have a method to display the name and registration number. Public method. Say display and sys out. Just I'm creating a class here, that's it. Name plus reg number. So our class is ready. Now what I will do is I'll go and create two student objects. Say first student object, student, we'll call him S1. He's a new student. Say student name is Satish, and his registration number is 123. Likewise, we'll have another student object. Student name is S2. Say object name is S2. His name will be Ram, and 124 is registration number. Now I should create an array list of student objects. So how will I create an array list? You just give a new array list you're creating. So it's array list, right? So array list, what kind of objects? So you have to give student here. Student objects. So I'll call this my class. So array list of all my objects from my class, student objects from my class. And then how will I add my students objects to my array list? My class dot add, and then what is my object S1 I'm going to add. Likewise, my class dot add, I'll add another object S2. So it just pushes it to the array list. So now it's not add all, it's add. If I want to traverse through my array list, how will I perform that? I'll create an iterator. So let me create an iterator here. Oh, it's an iterator, and it's of going to iterate on student objects. So I'll call the iterator itr is equal to my class dot iterator. Now I will traverse through every student object while itr dot ask next. I can go and do a read every student object from my collection. How will I read? ITR.next will fetch me every student, but I should move it to my student object, right? So I'll have student T is equal to, I'll typecast it to student. So I'll retrieve every object and I'm just typecasting it to student, and then let me print this sysout T dot name plus T dot registration number. From my array list, I'm just traversing using an ITraitor and printing all my student data. So when I run this one out, I should get Satish 123, Ram 124. So that's what a collection can hold anything. It can be a user defined object or any object that you want, either strings or integers, whatever.